Hi everyone, welcome to the Imply booth at the Kafka Summit. If you're not familiar, Imply is a provider of an open source technology known as Apache Druid that integrates seamlessly with Apache Kafka to allow users to analyze both batch and streaming data. But before I get into the specifics of how Imply works and talk more about the company, I want to give you a high-level overview of what we're going to be talking about today. So we're going to start by introducing the company, the product, and the platform. Then I'm going to be talking at a high level about the analytics stack and what it looks like to be doing analytics in real time. And then I'm going to present a demo and just briefly show you some components of our product. And then I'm going to wrap it up with a Q&A. So if you have any kind of questions, please feel free to enter them into the Q&A section in the conference software rather than blurting them out during the presentation. There will be, allocated time at the end of the presentation for me to go through and answer any kind of questions that you pose there. So if you have any questions about anything at all, anything from where I got this nice shirt to how Imply actually integrates with Kafka, feel free to ask it there. But before we get to the Q&A, let's talk about introductions. So Imply, as I mentioned, is a company that provides self-service hot analytics through a real-time data platform. We were founded back in 2015 and are funded by a number of venture capital companies throughout Silicon Valley, including Andreesen Horowitz, Geodesic Capital, and Khosla Ventures. We have some really, really strong VCs backing us who truly believe in the vision of hot analytics. And I think it's important to take their opinion seriously in deciding whether Imply might be a good fit within your own stack. So as a company, we're headquartered in California. Our office is actually in Burlingame, just south of San Francisco, but we've got employees spread out all over the world. We've got employees in APAC, in the Australia Pacific, in Europe, Middle East, and Africa, and a lot of employees spread out across the US. So we have a lot of different customer groups. We have customers all over the world, just like we have employees all over the world. And we've got customers ranging in size from Twitter, Walmart, Amazon, Atlassian, all the way down to little startups. So there's a whole range of different companies who find Imply useful. And I think you might find this useful as well if you're in need of analytics solutions on top of streaming data. Finally, in terms of the company introduction, I want to give you a brief overview of the technology. So Imply is built on top of Apache Druid, which was innovative and pioneered the use of real-time analytics on top of both batch and streaming data. And I'm going to touch a little bit more deeply on what this actually means, but from a high level, it means that when we're trying to do exploratory data analysis, when we're trying to really get to the why, the root of the question of why do these things happen, it's not enough to have second query response time. We need sub-second, we need second query response times so that we can have not just read a book about our data, but actually have conversations with our data. So that's a little bit about the company. Now, let me talk a little bit about the scope of the technology and the marketplaces that exist right now. So as you are doubtless aware, there's a big prevalence towards using data warehouses. And data warehouses are hugely useful and very important for certain use cases, right? But when data warehouses try to support hot analytics, when they try to do sub-second querying, when they try to have the type of conversation with real-time data that I was talking about earlier, fundamentally they struggle. And the reason for that is their ingestion process. So data warehouses traditionally ingest data in a batch processing capacity. This ingestion might be pretty quick, but it could take minutes to hours. And as a result of that, users don't have access to data as quickly as they need it. Now, in addition to ingesting a little bit slowly and therefore having stale data, the other issue with data warehouses when it comes to hot analytics is the query response times. The queries in data warehouses, even super fast, cutting edge data warehouses, still generally end up taking seconds to minutes. Which is okay when you're building a simple dashboard or generating a weekly report, but when you're trying to deeply dig in and explore your data, it's simply not fast enough. So while these processes and while data warehouses are useful for static reporting, fundamentally, when you want to get into hot analytics, when you want to get into exploring your data and being able to truly understand it, you need something faster. And that's where Imply comes in. Because in addition to being able to do the type of batch processing and ingesting data from data warehouses and data lakes, Imply also has the ability to take in stream data. So the process here changes from, this batch processing ingested into a data warehouse and then being fed into analytics tools and reports, and it goes to stream processing using message bus services like Apache Kafka, maybe powered by a vendor like Imply, and then feeding that into a real-time analytics database. And then from the real-time analytics database, using some kind of self-service analytics or visualization tool that's specifically built for that type of real-time analytics database. And this is where Apache Druid came in and really changed the game, because Apache Druid provided a compute technology that fundamentally filled this real-time analytics database role. So if we dig down into specific technologies, you can use something like Apache Kafka or Apache Spark with Spark streaming to feed that data into Apache Druid. But then the question becomes, how do we visualize that data? How do we actually interact with that data? It's great that we can generate, queries to get results back. But at the end of the day, the most intuitive and natural way for us to see data isn't generally in the form of tables, but in the form of data visualizations, which is where Imply comes in. So Imply, which was founded by the co-creators of Apache Druid, takes Apache Druid and extends it a step further by creating something called Pivot. Now, Pivot is a visualization technology, but it goes above and beyond technologies and tools like Tableau, Power BI, and Looker, because it seamlessly integrates with the underlying compute engine, in this case, Apache Druid, to provide users a seamless experience for interacting with and exploring their data. So the type of data that you can use for hot analytics is basically any kind of data that you have. So if you already have a data warehouse, as I'm sure many of you do, you can actually ingest data from that data warehouse into Apache Druid. In some cases, we completely replaced data warehouses that were being misused and attempted to use for hot analytics unsuccessfully. But most of the time, we actually find ourselves working really well with data warehouses and supplementing them because we fundamentally perform complementary roles. In addition to being able to take data from data warehouses, it's also possible to replace data marts and to take data that would normally be sitting statically in a data mart and instead to stream it and process it within Imply and within Apache Druid. So similarly, we can replace or accelerate legacy workloads that are currently on technologies such as Hive and Presto, which are really, really good for some particular applications, but simply don't get the job done quickly enough for hot analytics. And the last batch of technologies that I want to talk about is message bus systems, such as Apache Kafka. Now, Druid was really built to integrate with these types of streaming technologies. While we do also effectively integrate with technologies with batch ingest processes, such as Hadoop or Hive, we really excel and take a step beyond our competitors with our ability to not only ingest data in real time, not only stream in data in real time, but actually process it as it's getting ingested in real time as well. And that's where the speed of Apache Druid comes in and is especially important. Because when you're dealing with streaming data, the reason that you care about streaming it in is because the staleness for how new that data is matters. So why would you be wasting your time using a streaming service if you're only going to be doing batch analytics? That's why you need to be able to do streaming analytics with a solution like Imply. So that was kind of a high-level overview. Now we can break down the technology stack and understand the architecture of how Imply actually deals with all of these different use cases and all of these different incoming data sources. So starting from the bottom of the stack, as I mentioned, you can intake data from data lakes sitting on the cloud or on-prem, from message buses such as Apache Kafka, or from data warehouses. So from there, this data gets brought in via a data loader, which is a technology that I'll show you later. We have multiple connectors that we've built out, and you can even do a little bit of ETL within Imply. Now, after you've ingested the data, you can do processing with Druid, the open source technology, as well as with some custom Imply Druid extensions, which take the existing power of Apache Druid and actually amplify it by increasing the amount of capabilities that we have from there. But just having a compute technology isn't enough, as I mentioned earlier, right? We also need to be able to visualize. We also need to be able to actually analyze the data that we have coming in, which is why, in addition to the underlying compute technology, we also have this UI. So we have Pivot, which enables us to create dashboards, drill downs, and other types of visualizations. We've got an alerting system, which enables us to receive an alert every time data goes beyond a certain bound. And I'll show you exactly what that looks like within the product. And finally, we've got Imply Explain, which is a really handy feature within Pivot that allows you to dig deeper and ask the question of why. Why is it that I'm having a spike in production at this time? Why is it that there's this anomalous data coming in right now? Is this actually something that should indicate that we need to take an action? Or is this within the bounds of okay? Now, finally, on top of these UIs, or I guess in addition to these UIs, we also have a management and security layer. So we've got Imply Manager, which allows us to manage the cluster that all of these things are going to be running on. We've got Imply Security, which I'll dig into a little bit deeper, which allows us to integrate with LDAP and provide RBAC solutions for our customers. And finally, we've got Clarity, a custom-built Imply tool that allows you to monitor the cluster in real time using the exact same technologies that are actually powering the cluster itself. So as a result of all of these different interfaces, tools, technologies, all of these different parts of the stack, we can have a lot of different applications. So we see people using BI tools that are integrated directly within Imply. For customers that are already using Looker or Imply, they can continue using those types of technologies. They can build their own custom visualization framework. We can integrate with a number of different APIs. You can build out dashboards and reports, either using something like Pivot or using a technology or a tool that you already use. You can do real-time analytics using the technologies and tools that we provide, root cause analysis to figure out why are these things happening with my data, and finally, interactive data apps, meaning that you can actually use Imply to power some of the applications that you might even surface to your end users. A specific example of somebody doing that is one of our major customers, Twitter, uses Imply to power one of their customer-facing visualization tools. So in today's demo, I'm going to be focusing specifically on network data. Now, I come from more of a data science background. I'm not a traditional network engineer. I have some understanding of TCP and how data gets transmitted across the internet, but fundamentally, that's not my strong suit. What is my strong suit, though, is being able to show you how you can use Pivot and use Imply to understand the underlying causes of what's going on within your data set. So, like I mentioned, I'm not really an expert on network data. I'm sure that there's people in this audience who know a lot more about network data than I do. But my understanding of why so many of our customers like Imply, why so many of our specifically network data analyzing customers like Imply is for a number of reasons. So the first thing is that we provide a single pane of glass for all of the different data and all of the different analytics that you want to perform on your streaming data. We can integrate multiple data sources into a single pane of glass, allowing you to visualize everything from your geo IP data to your syslog data to your BGP data. And the reason that this is important is because when you're trying to get to a fundamental question, when you're trying to answer the question of why is this happening, it's incredibly inconvenient to have the friction involved with having to switch between windows, between tabs, between tools and technologies in order to be analyzing a single question. So this single pane of glass solution is hugely important for our customers who analyze network data. Additionally, we have join and lookup technologies, which allow you to bring together, as I mentioned before, data from disparate sources, which is really important when you're trying to enrich your data and understand how it relates to other data that you might have. So in addition to this join and lookup capability for combining data from multiple sources, the ability to use Pivot to easily drag and drop, to use this graphic user interface to have a conversation with your data and therefore quickly get down to the root of the question that you're asking is hugely important. Now, in addition to that interactive component of Pivot, Pivot also provides a really convenient dashboarding feature, which enables you to know what's going on, enables you to track and monitor what's going on within my network in real time. In addition to Pivot, there's also Explain, which, as I mentioned earlier, enables you to ask the question why and have the computer try to give you a response. In addition to explain, one of the other major advantages of using Imply and using Apache Druid for monitoring your network data is its scale-out architecture. Now, we've got some major customers, as I've mentioned before, and some of our largest customers are actually telecom customers who use Imply to monitor what's going on their networks. And quite simply put, a single machine would not be enough to be able to monitor the extent of the network data that they have, which is why Imply's intuitive and natural scale-out architecture is hugely important. Imply has the ability to scale out theoretically infinitely because of our horizontal scaling solution. Distributed computing means that instead of having to continually bulk up and beef up a single machine, you can simply allocate more of the same type of machine to the process and thereby scale out your architecture simply. In addition to being able to scale out, the search capabilities of Imply are hugely important for analyzing log data, which is the majority of network data that we see coming in. Additionally, time series visualizations are super easy and intuitive with Imply. Another useful feature that we find admins and network data analysts employing are alerts. As I mentioned earlier, you can just simply set a threshold, and when some particular metric goes beyond that threshold, it'll send an alert via an email or a webhook, maybe via the Slack integration. I'll touch on all of this a little bit later. One of the other reasons that I want to talk about Imply for network data specifically, and especially at Kafka Summit, is because of our integration with Kafka. We've got a very natural Kafka plugin, which I'll demonstrate how easy it is to bring data from Kafka into Imply. And finally, the fact that we work both with cloud and on-premise solutions. We know that a lot of our customers are maybe currently going through the transformation into the cloud. Maybe they've already gone to the transformation into the cloud, but some customers are going to be sticking with their on-premise solutions maybe indefinitely. And that's why we think that it's important to emphasize that we're not only a cloud solution provider, we'll work for everyone. So in this situation, we're going to be taking in a number of different data sources. We're going to be bringing in streaming telemetry data. We're going to be bringing in telegraph pipeline and SF load data. And we're going to be integrating all of this data into a single dashboard and analyzing all of it holistically rather than having to have it separated out. The basic flow architecture for the data coming in is that we're going to have BGP and flow data coming in, being integrated with syslog data, as well as data directly from our routers, switches, firewalls, and hosts. All of this data is going to be minimally processed through an ingest application and then brought into Apache Kafka, where we'll leverage KSQL to do some simple hostname mapping, some microservice name application, some microservice name mapping, some application name mapping, and some routing lookups. And after doing all of this data enrichment and data enhancement with KSQL, we're going to feed that data into Druid and then use Imply to analyze that data. From there, we can feed this data back into S3, put it into a data lake, and thereby it'll be accessible by a technology like Apache. So like I mentioned, I'm primarily going to be focusing on network data in this particular situation. And for network data in particular, there's a number of different use cases that we see. One of them is around performance management, right? Which intuitively makes a lot of sense. You want to make sure that your network is functioning well, that streams are being processed quickly, that data is being able to be transferred across the network very quickly. Another thing that we can do with another use case that we have for Imply and for Apache Druid within the network use case in particular is around DDoS, right? It's becoming incredibly important, increasingly important for network administrators to track incoming requests and make sure that they can quickly respond to potential DDoS attacks. In addition to preventing DDoS, it's useful to have a general idea of what type of traffic is coming into your network so that you can make it more efficient and thereby traffic engineer and make sure that the network data, that the incoming traffic is being redirected correctly within your network. In addition to traffic engineering, there's also the anomaly detection use case, which really feeds back into DDoS defense, but is a broader scope than that, right? Sometimes the issue is that you're being attacked by a hostile agent, but sometimes there's just an anomaly in terms of, oh, there's a lot of people trying to use my system right now. We should scale up the amount of nodes that we're allocating for our network processes. So in addition to anomaly detection, there's a number of different use cases for Imply within network data. I won't get into all of them, but I think you'll very quickly be able to understand how multivariate the applications and uses of Imply are. In addition to being able to talk about network data, Imply is hugely useful for a number of different data types. I personally interact with a lot of customers and users who use it for clickstream analysis, for doing simple OLAP queries. We have some customers who use it for risk and fraud detection, anti-money laundering campaigns, other customers who use it to power their digital ads. So there's a whole lot of different applications and use cases. But as I mentioned in today's presentation, I'm specifically going to be focusing on network data. So that brings us to the end of the presentation component of today's session. And I'm excited to show you guys a little bit about the demo. So let me dive right into the product here and show you what it is that I've been talking about this whole time. This is Imply. So specifically, this is the pivot interface within Imply, which gives us two particular types of visualizations that we can explore. And I want to start off with the dashboards. So as you can see, we have a number of different dashboards operating within this account. I'm going to specifically look for the network dashboard, network data operational view, open it up. And as you can see, it loaded pretty quickly and is showing us something that looks, pretty similar to what you might expect from any kind of dashboard. What's really interesting about this particular dashboard, though, is what's going on under the hood, right? Because there's not just a single source for all of this data. We're actually integrating data from a number of different sources simultaneously. There's a Kafka stream coming in with KSQL upstream, pre-processing and enriching the data, performing a map and a lookup ahead of time in order to bring enriched data directly into the Druid product. We've got other data sources bringing in BGP data. There's a lot of different types of data sets, all being seamlessly integrated within this single pane of glass, within this single solution. And what I particularly want to show you is just that we've got a lot of different data coming in from a lot of different sources, but how quickly I can look at, and I can analyze this data that we have coming in. So right now, we're looking at the data that's come in over the last day. But let's say I want to zoom in, and in particular, focus in on the last 6 hours. So do you see how quickly I was able to slice and dice the data and zoom in on the last 6 hours? Let's zoom out again, and this time, let's go back for the whole last week. As you can see, this whole dashboard updates in response to the changes in filter that I applied here. Now, let's say that I found some interesting anomaly in my data. Let's say, sometime around here, and I want to filter in and select this set of the data in particular, this subset of the data. As you can see, when I interact with a data set, when I select a particular use case, when I select a particular timestamp within it, it'll actually update the data throughout the whole dashboard, applying this filter throughout the whole thing. Now, if we deselect that particular limitation on the data and go back to the latest day, we can see the existing incoming data from the last day. It looks like my computer is having some issues loading the most recent version of the screen. I'll need to refresh my page. There we go. So in addition to being able to filter by time, we can filter by any of the other metrics or dimensions that we have within our data. So let's say we want to zoom in on a particular IP protocol. So let's say I'm really interested in TCP traffic coming in. I can simply select TCP, and from there, it'll update all of the different dashboard visualizations to show this in real time. I take it, I think one of my colleagues is probably also using this cluster at the same time, which likely explains why it's taking a little bit longer than it normally does to load everything. But as you can see, the dashboard updates relatively quickly, even when there's a pretty heavy load being put on the dashboard. We'll backtrack actually to the dashboard view later, but because we're experiencing a little bit of slowness in our queries, this is a great time to show a different part of the Imply product. Specifically, we can look at clarity. Now, if you look at the clarity interface, you might notice that this looks a little bit familiar, right? It kind of looks like a dashboard that we might have built out in Imply. And that's because it is. Clarity is a tool that Imply built on top of Pivot, which allows users to leverage the same real-time processing capabilities, the same simple BI tool visualizations that we use to analyze data about everything from network traffic to clickstream, and instead use it to analyze what's going on my cluster. So if I want to analyze my cluster, if I want to understand what's going on in my cluster, I can use Clarity to understand why are my queries coming back a little bit slower. And you can see that we can zoom in on a particular period of time and look at this spike of why are my query response times slower here. Okay, well, it looks like most of the queries in this period of time are coming from the NetFlow PGP, the NetFlow PGP and the BGP routing data sets. We can see that the types of queries being applied are primarily time boundary queries, which actually explains why things are running a little bit slower than usual, because we're seeing a lot of very heavy queries that take a lot of processing power in order to compute, which explains why the cluster overall is running a little bit slower than we'd expect. So I won't dive too deeply into the Clarity interface, but as you can see, it's a very useful tool, a very useful solution to understand what's going on my cluster, what's happening on my cluster, and more specifically, what should I do to tune my cluster to be able to get the type of sub-second query response times that I expect when I use Imply. So navigating back to the Pivot interface, now that we kind of understand what else is going on this cluster, why it is that it's running a little bit slower, let's take off the filter that we applied previously, reset it to show all data from the previous day, and let's zoom in on a particular spike that we might see in the data, a particular anomaly that we might find interesting. Let's zoom in on this time period. Actually, rather than just zoom in on that time period for the whole data, let's zoom in on this particular visualization, filter to select that particular anomalous time in the data. And from here, we can use this simple drag and drop interface to show more dimensions and thereby get a better understanding of what's going on here. So we currently are using this single line chart, right, to understand what's the average speed of network traffic during this given time. But if I drag in another dimension, I can have it broken down by different IPs. And we can see that when we break it down by different IPs, it turns out that there's a pretty significant change in the averages or in the amount of time. So it looks like there's one particular IP address that's causing most of the slowness, right? You see this, the blue line is really the only one that's very prominent here. And if you take a look at the data during this particular spike, we can see that this IP address associated with the blue line, the IP address starting with 10, is actually running over 10 times slower than all of the other IP addresses. So this kind of explains why we see this spike, why we see this slowdown coming in here. Now, let's say that we're a network administrator and we want to have a better understanding of, we want to monitor and we want to like make sure that when we see this kind of slowness, we get alerted in real time so that we can redistribute resources to prevent exactly this type of slowness. From here, we can actually navigate to the alerting section. And we can set an alert. I'm just going to edit an existing alert. Let's say this network NetFlow Kafka alert. Let's edit it. So we obviously want to name our alert. We can set severity for it. So what type of an alert is this? Is it just, info? Is it a warning? Is there an error? Is it saying that everything's okay? Diving a little bit deeper though, what's most interesting about the alerts is how we can set them off, right? What type of trigger events do we have to set off these alerts? So we can either just have it be a threshold alert, meaning let's say, diving specifically into the traffic use case, let's say if it takes longer than 10 seconds for somebody to get a response from our server, then send me an alert. Or instead of doing a threshold, we can do a comparison. So we can say, if it's taking 10 times as long to return as it did last week, then send me an alert and I'll redistribute. This type of alerting software or this type of alerting technique is really useful for helping administrators, operations teams make sure that their network is operating to the extent that they want it to. By default, what happens when you set up an alert is it'll send an alert via email. But additionally, we can actually use webhooks to create an alert, and we can either use a custom webhook or this specifically created Slack integration webhook, which will allow you to notify your users in real time in Slack whenever an alert gets triggered. This is incredibly useful for ops teams who are already used to using Slack for technologies such as PagerDuty to now get alerts on different parts of their data via Imply. So we've talked a lot today about what to do when the data has already been brought into Imply. But the last thing that I want to show you as part of today's demo is how easy it is to bring new data into Imply. And in order to do that, we're going to use the Imply Druid, the Apache Druid data ingest, the data loader tool. So as you can see, we've got a number of different areas that we can load our data from. Right, we can bring in our batch data from S3. We can integrate with GCS or with Azure Data Lake. We can even get data from an API by simply getting data from HTTP source. But I think what's going to be most interesting for this group in particular, given that you guys are at Kafka Summit, is Apache Kafka integration. Right, is the ability to easily ingest data from an Apache data source and sync it directly into Imply. So rather than create a new spec from scratch, I'm going to look at some of our existing data sources. I'm going to select one to show you what it is that we do. So far, we've mostly been looking at this BGP routing data. So I'm going to take a look at that ingestion spec. So as you can see, this is the data that's coming in through this BGP routing data source. We've got some timestamp data, which is the timestamp of when traffic is occurring. We've got a number of different fields. Now, what's important to note is that the types of fields and the number of fields that you have coming in when you are associated with a sync can actually be dynamic. So if you change something upstream, if you change the data coming in via the Apache stream, or the Kafka stream rather, you actually don't need to make any kind of modifications to the spec within Druid. So if we want to ingest data or load data from Apache Kafka, well, the first thing that we need to do is identify our Bootstrap server. I don't remember the IP address of our Bootstrap server off the top of my head, nor do I remember the topic that's associated with it. But what's important to note is that as soon as you populate this Bootstrap server in this topic, the consumer properties will automatically be populated in there. We have a separate tab for parsing the data. So once we've gotten a small sample of the data, we can start to analyze and understand, okay, what are the columns that we need to generate from there? We specifically have a separate tab for parsing the time series data, which is hugely important within Imply because we are a time series focused OLAP database. You can provide certain transformations or filters, just like you can do with KSQL, with a little bit more depth with Imply. And then from there, you can do some particular tuning to make the ingest process as efficient as possible. And then once you're done with all of that, once you've created your spec, you're on your way to successfully ingesting the data and being able to access it through the Imply interface up here. So that brings me to the end of today's demo. Let's navigate back to the Kafka Summit page. I'm going to stop sharing my screen and take a look at the QA. Ooh, okay. So there's a great question from David about whether Druid is stable in Kubernetes. So the answer very simply is yes. We love working on top of Kubernetes. Kubernetes K8s is a really great tool, a really great deployment manager, and is really powerful in that it allows you to scale out exactly the way that Apache Druid and Imply like to scale out. It allows you to scale out while being a little bit independent of the resource types that are underlying. I don't know off the top of my head of any famous use cases, but I know that many of our customers do sit on top of Kubernetes and do use Kubernetes. Another question that just came in from Juan, why should we use Druid and not Kudu? Now, I'm definitely not a Kudu expert by any means. My understanding is that there's a pretty significant performance difference between Druid and Kudu, that Apache Druid runs quite a bit faster than Kudu. But the other thing that I would say is that it's worth considering not only the underlying compute technology, but also what's built on top of it, what's sitting on top of that compute technology. So, in today's presentation, I've talked a lot about Apache Druid, but Imply as a platform goes above and beyond simply talking about Kudu, above and beyond simply talking about Apache Druid, and actually shows features such as pivot, such as alerting. So the question isn't really Druid versus Kudu, it's Imply versus, I don't know, maybe like Kudu sewn together with like Tableau or together with Looker or Power BI. And the answer fundamentally is that there isn't any other tool in the marketplace, no other open source or vendor technology that integrates the compute and the analytics component as seamlessly as Imply does. That's a great question. Yeah, I'm actually not hugely familiar with Pinot. I'm sorry, I can't speak to that personally. If you're interested though, feel free to reach out to Nolan or to me personally. I'll be able to get back to you with a response from somebody who would have a better answer for you than I do. I unfortunately am just not that familiar with Pinot, so I don't have a good answer for why you would want to use Druid or why you would want to use Pinot for whatever the application or the use case that you're using is.
Danny, we had a question that was asked both in the chat window and in the questions, and it's about join. Can you update on joins? Apparently last year, this person obviously couldn't use joins, but can you talk about what's been happening this year with joins, an update?
Yeah, absolutely. So that's absolutely right, that last year joins did not exist as a technology within open source Apache Druid or within Imply. But now they do exist. So now, as I demonstrated in today's demo, you can bring in multiple data sources together, and you can even use simple SQL joins. Here, I can provide a particular example within our UI. If I navigate to the SQL interface, and go to saved queries, and as you can see, we're using two different data sets. Coming from two different sources, actually. One of them is, I'm sorry, I'm not sharing my screen anymore. So I've got this SQL query within the SQL interface for Imply. And as you can see, I'm joining in real time, streaming data coming in from Kafka to an existing table that I have that'll allow me to look up the connection between a particular IP source and a message that I have saved ahead of time. So as you can see, joins work. They are definitely part of the Imply platform. I actually don't remember off the top of my head whether they've already been integrated with the open source Apache Druid, but if not, I expect that they'll come out within the next 6 months. So long story short, yeah, a year ago, joins didn't exist, but now they do.
All right, so let's see if there's any other questions here. Let's see. There was one about how does Pivot stack up against traditional BI tools like Tableau and Power BI? You might have already covered that, but I thought I'd just ask it.
Yeah, I can dive into that a little bit deeper if that's an interest area for people. So the long and short of it is that while Pivot looks a lot like those traditional BI tools, fundamentally, it's doing a very different thing. While those types of traditional BI tools are primarily used to generate reports or dashboards, so very static pieces of information, very static ways of representing data, Pivot is fundamentally created to allow you to have a conversation with your data, to allow you to ask questions of your data and get answers to those questions in real time. So while, I could talk about the different types of visualizations that we have maps and pie charts and line charts, none of those things really distinguish any type of BI tool from any other BI tool, right? Like Looker, Tableau, Power BI, Superset, all of these different tools have all of these different types of visualizations. The real difference, the clincher, the thing that makes Pivot stand out is its direct integration with Apache Druid. Is it the ability to seamlessly show and update data in real time, because it's not created to generate those types of static dashboards and reports that I was talking about earlier, but to allow you to have a conversation with your data and analyze it in real time.
I'd like to thank you for attending the demo and discussion today. I hope that you found it useful. I think, Jenny, you did a great job. And we really look forward to seeing you guys in the future at one of our summits. We have a virtual Druid Summit. If you go to our website, it's a free virtual event. And we're having speakers from lots of big companies, Netflix, Twitter, talk about their Druid usage. And it's next week, and we'd love to see you there. Okay, with that said, I'm going to stop talking. And again, Danny, thank you so much for the presentation today.
Sure, absolutely.